Physics, Dr. Frank Oppenheimer, was produced in cooperation with University of Colorado Television. Experiments in Physics with Dr. Frank Oppenheimer. A brief demonstration of the equipment used in the Library of Experiments in Physics, produced in cooperation with University of Colorado Television. Today's experiment.
This is an experiment in which one can study the resonance of air columns. Basic manipulations are very simple. One has an audio oscillator with a variable frequency and a little speaker that's driven by the audio oscillator, and one has air columns of variable length. Since there's water in here, and as one pulls this out, the air column is closed, as a closed column is from this water level up to the top of the column. And one can measure that with a ruler and find out the length at which there are resonances. At about 1,000 cycles now, one raises this up, there's a resonance. One can measure that and determine where it comes from the top of the water to the top of the air column. And then one can find other resonances at the same frequency. There's another one. And there's another one, and so on. And measure the distances between those resonances and the length of the column. One can do that for different frequencies as well. For example, at a higher frequency. Of course, in order to get the higher frequencies, this has to be very full, so that you assure you get the first resonance. You can hear as I go on up and get a great many resonances. And see how it varies with frequency. I'll turn this down for a moment. One wants to adjust that so that it's the amplitude so it's clearest. If it's too dim, you never hear the resonance. If it's too loud, the contrast isn't enough, and it's hard to get. The experiment is interesting not only because of the simple theory in which if you know the frequency and measure these resonant lengths, you can find the velocity of sound in this gas, but for a large number of other things that you can do. You could, for example, bubble carbon dioxide up through here. Although it's a closed tube, there are edge effects, and one can see how these edge effects vary with the diameter. There are two different setups that are similar, and there are some things that depend on the diameter. You can put a glass wool or damping in here and see how that affects the sharpness of the resonance. You can take this out completely and study, although we have no way of varying the length with this particular setup. We can vary the frequency, and you can see how the resonances occur with an open-end tube. I think we'll need a lower frequency. And notice that these speakers has a lot of harmonic distortion, and some of the resonances emphasize that harmonic distortion. There's clearly some sort of a resonance. And so on. So one can study both the closed tubes and the open tubes and see if these behave the way one would expect them to do, but also study all these various side effects that can come in. It's a rather pleasant but a very simple experiment.
Experiments in